Hey guys, this is Mr. Holly. Today we're going to be looking at the baseball card task. The point of this task is to look at something called percent of change. So we are just going to be looking at what is the percent of change that's happening here in this student's baseball card collection. So I will read the task to you, and then it's actually it's meant to be a task for students to kind of experiment, to draw some pictures, to try to represent this visually, and then come up with a numeric answer, and then we discuss that in class. So I want to give you the opportunity to do that at home, and then I'll kind of discuss what you probably should have, the conclusions that you should have made as you explored this on your own. The problem says Will increased his baseball card collection by 5 cards. He originally had 20 cards. What is the percent increase? Justify your answer using a numeric and visual model. So in this space, I'd like you to draw some kind of model for what's happening in the situation. And I'd like you to use that model to decide by what percent did his card collection increase. And then come down here and use a numeric model, and I'd like you to decide by what percent did his card collection increase using some kind of expression. All right, and you can pause the video now and attempt that at home. All right, so let's take a look at this, and we can think about this in quite a few ways. So I'll kind of give you some different varieties. Potentially you chose one of these, potentially you chose something similar. So one of the methods that you could possibly use is just to draw out 20 individual baseball cards, right? Draw all 20 and then come back and draw like 5 more cards. If you drew out all 20 of these baseball cards, you could then think about, if I had 20 cards, what percentage of my collection is each card? So 20 cards, what percent would that be for each card? And that, obviously, that would be 5%. Each card would be 5%, because 5 times 20 is 100, so 5% times 20 cards would be 100%. Each card is worth 5%. So that means adding an additional 5 cards would be like 5% each. And that would be an increase of 25%. Another way you might have thought about it is, I have this entire collection of cards. This collection of cards is 20 baseball cards. That's 100% of my collection. I'm adding an additional 5 cards. Well, if I look at this original 20, if I were to break this up into groups of 5, how much would each group be worth? Well, 100% divided into 4 groups. Each group of 5 is worth 25% of my original. That's 5, 5, 5, 5. Each group of 5 cards is worth 25% of my collection. So an additional 5 cards would be an increase of 25%. So what you see here is a 25% increase. Numerically, we would just look at it like this. We would say the formula that we use is change over original. And we would look at 5 cards is the amount of change, like it changed by 5, and 20 was my original amount, so that is 5 divided by 20 is 25%. You can go back to our original equation that we learned in lesson 2, part equals percent times whole. And really this is just a variation of this equation, right? Like what part of the whole, what percent of the whole is this new part, right? His whole card collection was 25 cards. Excuse me, 20 cards. He had 20 cards. He's adding 5 cards. That is what percent of 20? Like what percent of 20 is this 5 cards? Well, we would just divide both sides by 20. 5 over 20 is equal to X, and that's 25%. The idea here is that we are comparing the new part, which is this addition, or perhaps it is a decrease. Either way, we're comparing this change to whatever our original amount is, and that is the key. The denominator here is always going to be your original amount. Sometimes one of the misconceptions a lot of students have is that they try to put the largest number, so they may use, in this case, the new amount of cards was 25 cards after he got the new cards added in. So they want to put the biggest number they can as the denominator. That is not true. When we talk about percent of change, the original amount that the person begins with is always the denominator. Okay, so whatever the scenario is, denominator is always the original amount. All right. So the answer to our baseball card task is that his collection increases by 25%. All right. I'm going to flip the page here, and we're going to look at another problem. We're kind of going to edit this down just a little bit. We're not going to do the whole thing. A says to write 2 inequalities comparing the percent increase from 1970 to 1980 and the percent increase from 1980 to 1990. So that's this increase and this increase. So the first thing we would need to do is figure out, remember our formula is change over original. So we need to figure out by what did this change? Like how much change is there in these two amounts? And that is a change of 37 cents. And this is a change of 55 cents. Now you may be thinking to yourself, 55 cents is more than 37 cents. But that doesn't mean that it is a greater percent of change. Let's check and see. To find the percent of change, I would take 37 cents and I would put it over the original price, which was $1.23. And I would take 55 cents and put it over the original price, meaning we're looking at the change from 1980 to 1990, so the original price is the cost in 1980. So that would be $1.60. So let's see which one actually has the greater percent of change, not the greatest change, but the greater percent. 37 cents divided by $1.23 is a 30% change. 55 cents divided by $1.60 is a 34% change. So this is, in fact, a greater percent of change, and it is obviously a greater amount of change. But it could have been a greater amount of change, but still not been the greatest percent of change, right? Like if this had been 40 cents or 45 cents, that would have been, like 40 cents would have been 25%. And even though 40 cents is greater than 37 cents, it is a smaller percentage of the original. So it's important to realize that this question is asking you to compare percent of change, not amount of change. Hopefully that is clear. So 2 inequalities, we could say that 30% is less than 34%, and 34% is greater than 30%. We're not going to graph these, but we are going to look up here and we can determine which decade had the greatest percent of increase. Okay, so we've already figured out this is from 70 to 80. This is from 80 to 90. Let's do 90 to 2000 and then 2000 to 2010. So 90 to 2000 is 55 cents. And 2000 to 2010 is $1.70. All right. So the first one there is 55 cents. And the original price, when we're talking about going from 1990 to 2000, the original price was $2.15. And then from 2000 to 2010, it was a change of $1.70, and the original price was $2.60. All right, let's see what percentage we get with each of these. 55 cents divided by $2.15. That's going to be approximately 26%. Some of you may have noticed, before we even did that, you might have thought to yourself, well, there's no way that this is going to be greater than the change from 1980 to 1990, because it's the same amount of change, but the denominator here, the initial cost in 1980 was less than the initial cost in 1990. So while they both increased by the same amount, this one obviously increased by a greater percentage because it started at a lower amount. Little number sense, maybe you picked it up, maybe you didn't. Okay, $1.70 divided by $2.60. That would be 65.4, let's just say approximately 65%. And this is by far the greatest percent of change, 65%. Honestly, when looking at this table, it's pretty evident, you know, this didn't quite double, but it definitely went up by more than half, and it's the only one that was even close to going up by more than half, right? Half of 260 is $1.30. None of these came close to going up by an additional half, right? Like all of these are less than 50% increase, obviously. This one was obviously greater than a 50% increase. So you may have even just been able to look at that table and kind of estimate in your head before you even found this amount to know that the decade with the greatest percent is from 2000 to 2010. All right, so again, continue to use this idea of change over original. You're just going to find the difference here between the original amount and the new amount. That's your change. So you could say like new minus original. It's always going to be a positive number though. We always want this to be, so you could think about it as the absolute value of that if you need to. But just going to do the change over original, and whatever percentage that gives you is your percent of change. All right, you've got some problems to work out on the next page, and that's going to be your problem set for this lesson. Thank you.